All right, what's up, y'all? Today I'm going to do the first of a series of lessons talking about modular synthesis using VCV Rack. VCV Rack is a free program. There is a paid version with extra features, but the free version is really incredible. There's so much you can do with it. Something I really think everyone should take some time to play around with. I've really enjoyed using it. And yeah, it's a great way to learn about modular synthesis, sound design, things of that nature. So, with this lesson, we're just going to do something pretty simple and basic. We're just going to build a subtractive synthesizer. Real simple. This does assume you have some knowledge of, sound design, music production, stuff like that. But we're not going to do anything too complicated. First, I'm going to need a MIDI module. MIDI to CV. So I am using a Arturia Keylab MIDI keyboard. For this, it's useful because if I'm trying to make a synthesizer, it'd be nice to have a physical keyboard that I can use for notes and gates. So yeah, this module is going to help us do that. So I'm going to select the Arturia Keylab. So now VCV Rack is taking the information from my physical MIDI keyboard and it's going to convert it to CV. CV stands for control voltage. That is kind of the universal language of modular synthesis. And yeah, we'll kind of get into what that means and how that works. There's different types of signals that are used in modular synthesis. There's audio signals, where if you patch an audio cable into some kind of audio output device, you'll hear sound, of course. There's volt per octave, which is note information. So CV can range from negative 10 volts to positive 10 volts, anywhere in between, up to like 3 or maybe more decimal places. And volt per octave is essentially between any single volt full value interval, like 0 to 1, that would be considered 1 octave note range. So if you divided that into 12, you could get the 12 individual notes. And that's what this guy helps us do. There's also gate information, which we'll be using in this video too. Gates are essentially allowing or triggering some kind of module to be open or to run through its cycle. So in this example, like if I press a key on the keyboard, that would be an open gate, which would be a positive 10 volts, versus 0, which would be a closed gate. So yeah, that's just some basic stuff. First and foremost, gonna need an oscillator. I'm gonna use all of the VCV Rack brand modules that come with the free version. And there's tons and tons of modules you can download for free and use in VCV Rack it's an open source program, so developers are making new modules. Some are paid, but the vast majority of them are available for free, which is really cool. I've downloaded tons that I like using. And yeah, really it's up to you. You can explore different makers that you like and yeah, kind of like help build your own library, if you will. So this is a VCO module from VCV Rack, voltage controlled oscillator. This is a sound generator. It's always making noise. We don't hear anything right now simply because it's not plugged into my little mixer. I have a few things up here. This is just a little mixing console, some delay, reverb, just to make things sound a little more pretty. But yeah, as soon as I connect this sine output, so like this oscillator, for example, has 4 different waves you can choose from. A sine wave, triangle, saw, square. So if I connect the sine output to my mixer, we get sound. Great. Now it's just running this single note because the oscillator is set to this frequency. So it's just going to play this note until I tell it to do otherwise. So I'm going to connect the volt per octave output of my MIDI console to the volt per octave input of this guy. And now, as soon as I start playing notes, we get new notes. Now, VCV Rack is also capable of polyphony, so I'm going to go ahead and set it to that. With this module, any module, if you right-click it, it'll give you a drop-down menu, which could give you some menu options with the module in case you want to set it to be able to do a certain thing. So, for example, I want to say maybe 4 channels of polyphony. Ooh, it's a lot louder now. So now this cable, let me bring this down a slight bit. Now this cable is a little thicker because it's got 4 individual channels of polyphony running into this module. Not all modules are capable of polyphony, but most of them are. But this one definitely is. So as soon as I start playing, few notes. Look at that. Now we've got 4-voice polyphony. It's only going to do 4 voices at once, which is fine. Now, it's just playing the note constantly because I've sent that note information, so it's always going to hold these notes out until I change the note, for example. But maybe we don't want it to do that. That's when we can create a little amplitude envelope. So I'm going to get a envelope generator. This one from VCV Rack is totally fine. And I'm going to get an amplitude module. This is a voltage-controlled amplitude module, which just messes with the amplitude of an audio signal. So I'm going to take this audio output, put it to the audio input of my VCA module, and then I'm going to connect the output to this. Now it's doing the same thing because this yellow bar is all the way up, so that's maximum amplitude. But as soon as I connect this envelope generator to the CV input of this voltage-controlled amplifier, it's going to go to 0. Simply because the envelope hasn't been triggered, so we're not going to hear a volume swell. That's where gates come into play. This has a little gate input, so I'm going to take the gate output of my MIDI console, connect it to here, and now this envelope is going to get triggered. This attack, decay, sustain, release envelope is going to get triggered and run only as long as I'm holding a key. There you go. Beautiful. And you can, of course, adjust it a little bit. I might make it swell a little more, decay slower, bring that up a little bit. Nice. I'm also going to go ahead and change this to a saw wave, just so I have a little more harmonic information. Cool. So, subtractive synthesis is the idea of taking sound that has a lot of harmonic information, using filters and other modules to rein in the sound a little bit and sculpt it. You're subtracting harmonic information, hence the name. So, I'm going to need a filter module. This is a voltage-controlled filter. So I'm going to go ahead and take the output from my amplitude and run it into my filter. So you've got two options here, a low-pass filter or a high-pass filter. I'm going to go with the low-pass, connect that back into my little mixing console. This knob is representing the cutoff frequency. So if I bring it up, we get more harmonic information. Cool, right? And yeah, if I bring it down, less harmonic information, of course. Now, right now I'm using my mouse to manually move the cutoff frequency, but that's annoying. Why would we do that? Why would we do that when we can assign something else to do that? So, great way to do that, especially with filters, is more envelopes. So I'm going to make another ADSR envelope generator. I'm going to connect the gate output because I want it to work in tandem with the same gate of the notes I'm using. And I'm going to connect the CV envelope output to the cutoff CV input of this filter module. Now, this little knob up here is an attenuator. I'm going to explain real quick what that does. But first, I'm going to bring up a scope module. When you first get into Modular, this guy is extremely useful to help you visualize what's going on with CV information. There's a lot of things that can be going on here, and sometimes you're not exactly sure what's happening. This can help you visualize it, which might help it make more sense and get you going down the path of righteousness. So I'm going to make a new cable, connect it to my scope here. So right now, this isn't activated. So we're just seeing the CV resting right at 0. Down here would be -10, up here is +10. But it's sitting at 0 because I haven't triggered the gate to activate it. But watch what happens as I play a note. There it is. We can see this envelope generator. I'm going to bring the sustain down a little bit. We can see the envelope generator activating in real time. It's going from 0 to +10 and then back down to 0. Very cool. We're all the way to 0. Great. So, an attenuator is essentially something that controls the amount of a CV signal going through something. I'm going to bring out this very useful module This has 8 different attenuator channels, just so I can show you what's going on when I plug it into the scope. So I'm going to take that envelope output, put it into my attenuator, take this output back into here. So attenuator knobs, when they're at 12 o'clock, that means the signal is not passing through at all. You can't see anything happening on the scope now, right? As soon as I start to turn this, you'll start to see the envelope, but it's decreased in amplitude, right? So now it's only going up a little bit and then back down. If you bring it all the way to the right, then we're back to fully open, 0 to 10 volts and back down. So that's what an attenuator does. A lot of modules will have attenuators built into them, but some won't. So a module like the one I was just using, very useful to get that effect if you need it. Since this already has one, we're just going to use it. Another important point, going to the right of 12 o'clock is going to give you the exact positive non-inverted value of whatever CV information is coming in. If you go to the left, it's just going to invert whatever you're sending to it. So it would take this same envelope, but make it go from 0 to some negative value. We want to do positive because I want the cutoff to go up and then back down. So I'm going to take this, bring it up, maybe not all the way, maybe like halfway, and we'll hear what that sounds like. Yeah, let's make the attack a little so. Cool. Make that decay a little slower too. Yeah, now we can hear. You can't see it visually happening, but this cutoff is now going up some amount of volts and then back down to its starting position, which is set to right here at 563. Can attenuate it a little bit if you don't want it to move up quite as much, or you want it to go up even more. Kind of like it right here. Cool. So that's a pretty basic automated subtractive synth. Just pressing some keys. And there we go. But I want to spice this up just a little bit. So I want to show you another cool trick to make a slightly more realistic sounding analog synth. So right now, we're just running the one oscillator in polyphony. So everything is in tune with itself because it's just coming from the one oscillator. And by that, I mean the individual notes. But I'm going to go ahead and duplicate this oscillator. Going to patch the volt per octave to the same volt per octave output from my MIDI to CV. So it's playing the same notes. I'm going to also take a saw wave as well. But first, I need another pretty important module I use all the time. This is the VCV Rack mix module. What this guy does, it's got 4 channels and it's going to mix up to 4 audio signals down to 1 audio output cable. So I'm going to take this out of here, put it into the first channel. I'm going to take this second oscillator's output, saw output, into the second channel. And we can see that there's some activity. This is now going to be mixed down to 1 audio cable, which I'm then going to put in to my VCA. Great. Now, this isn't really going to change anything. Now we just have 2 voices totally in tune with each other playing. So it's just going to be louder. But what I want to do is take the frequency of this second one and detune it ever so slightly. I'm just going to bring it up a little bit. Just a little bit. So on Windows, at least, if you hold Control while you're turning a knob, it'll decrease the sensitivity substantially, so you can fine-tune it a little bit more. You can also right-click any knob and input an exact value if you'd like, which can be really useful for trying to get extremely specific. Double-clicking will reset it to its initial state, but yeah, I'm going to bring it up just a little bit, so it's a little sharp, and let's hear what that sounds like. Ooh, you can already hear it. It's a little detuned. Cool. This helps create the illusion sounding a little more analog. I might detune it even a little more because I'm just crazy like that. Fun. All right. So now we've got kind of like a 2-voice polyphonic analog synth that's slightly detuned. But I want to get a little crazier. So the beauty of modular synthesis to me is creating all of these self-modulating or automatically modulating parameters to create a lot of movement within whatever sounds you're making. Great way to do that is an LFO. This is an LFO module, which stands for low frequency oscillator. This doesn't generate sound, it generates a CV output. So I'm going to actually plug this into my scope over here so you can see what I'm talking about. I'm going to lower the frequency so it goes real slow. I'm going to take the sine output, put it in my scope. There. So you can see the CV's going from 0 to positive 10 and back down at the rate I set it to. Can do even slower. Can do really fast. Look at that. Look at that sine wave go. This module also has an offset. It's set to unipolar, so it's going to be positive, 0 to 10 and back down. But if I click it to bipolar, it's now going to still be a 10-volt range, but it's going to go from -5 to +5. Cool. So I'm going to make it nice and slow. And I'm going to take this output and put it into the FM of both of these oscillators. FM stands for frequency modulation. So as you can imagine, the pitch is going to be modulated. My attenuator knob's right here. All right, 12 o'clock, so nothing's going to happen. So I'm just going to bring each of them up or down just a smidge. I'm going to bring this one up just a hair. That's maybe too much. Maybe just right there. I brought this one up to the right side, so it'll be reacting to this just as you see it. And if I bring this one down a little bit, it's going to be inverted. So as this FM for the second oscillator is going up with the sine wave, this will be going down, the inversion of this sine wave. Just so I can create some kind of cool phasing effect. Maybe not quite as much. Beautiful. Now let's give that a listen. It's almost too subtle. So let me exaggerate a little bit so you guys can hear. This might sound a little crazy. Ooh, you can hear that, right? Yeah. Bring this cut off. Yeah, cool. So now we're creating movement within the sound, makes it more organic, more exciting, breathes a little more life into it. So yeah, this is a super basic subtractive saw synth we just made. This is really just scratching the surface of what you can do with modular synthesis, with VCV Rack. This is a great place to start. So yeah, I'm looking forward to making more lessons. We'll talk about generative stuff, sequencers, clocks, all those kinds of things. Making an entire song in VCV Rack using generative patches. It's really, really a lot of fun. But yeah, that's all for this one. Thanks for tuning in.